We're going to look at another way we can solve trig equations, and sometimes it might be beneficial to use an identity and substitute in and then solve the equation. So here we want to solve 2 cosine squared of x plus sine of x minus 1 equals 0. And one thing that we have trouble with here is that we have cosines and sines, so it's hard to factor. Now we can use our Pythagorean identity, so we know that sine squared of x plus cosine squared of x equals 1. Well, if we solve for cosine squared of x, so we subtracted sine squared of x from both sides, we would have that cosine squared of x equals 1 minus sine squared of x. So we're going to plug that in for cosine squared of x. So that makes this equation 2, and then for cosine squared we're going to do 1 minus sine squared of x, and plus sine of x minus 1 equals 0. So I'm going to distribute the 2, so we have 2 minus 2 sine squared of x plus sine of x minus 1 equals 0. And if we combine like terms, we'd have, so I'm going to write this as minus 2 sine squared of x plus sine of x plus 1 equals 0. And now we want to see if this factors. Let's try factoring it. So since we have a negative 2 sine squared, that means we're going to have a negative 2 sine of x and a sine of x. And since we have a 1, we're going to have 1 here and 1 here. We need to think about, they either both need to be minuses or both pluses. You know what we can actually do is make this a 2 sign and make this a negative sign. Let's see what happens there. And make them both pluses. Then if we follow them out, we'd have negative 2 sine squared. We'd have 2 sine of x minus sine of x, which would give us the sine of x plus 1. Okay? So this is how we can factor it. And then we can set each of those equal to 0. So we can set 2 sine of x plus 1 equal to 0 and negative sine of x plus 1 equals 0. So when we solve here, we're going to get sine of x equal to negative 1/2. And we can look on the unit circle and say, okay, that's where the y coordinate is equal to negative 1/2. That happens at 7 pi over 6. And that happens at 11 pi over 6. Okay, then here we're going to have negative sine of x equals negative 1, which means we want sine of x to be equal to 1. And that happens at pi over 2. Okay, so our solution here is pi over 2, 7 pi over 6, and 11 pi over 6. Okay, let's do one more where we're going to use one of our identities to help solve. So here we have sine of 2x equals sine of x. So we're going to use the double angle identity for sine of 2x, and that's equal to 2 sine of x cosine of x. And we want to know where is that equal to sine of x. So the first thing we're going to do is get everything over on one side. So we're going to subtract sine of x from both sides. So we have 2 sine of x cosine of x minus sine of x equal to 0. Now I'm going to factor out a sine of x, since that's our greatest common factor. So we have sine of x times 2 cosine of x minus 1 equal to 0. So now that we have it factored into two things we're multiplying, we can set either of each of those equal to 0. So we want to know where is sine of x equal to 0 and where is 2 cosine of x minus 1 equal to 0. So sine is equal to 0 at 0 and at pi. Okay, and this is asking, well, we'd say where's 2 cosine of x equal to 1? So cosine of x is equal to 1/2. So where's the x? 1/2. Well, that's at pi over 3 and at 5 pi over 3. So our solution, we'd have this at 0, pi over 3, pi, and 5 pi over 3. So we can use the trig identities to then transform it into something else that we do know how to solve.